So far, we have visualized or analyzed data as they have been provided to us. But very often, we may want to change or transform data in some way before analyzing or visualizing it. So one example is you could have missing data, and that could make the visualization of plots difficult. And we dealt with this example in Module 2 Study Guide B. Another example might be that you may want to compute quantities that are not present in the data but that are based on the data. For example, in the iris data containing the petal widths and lengths of different species of irises, we may want to compute the proportions of the flowers to determine whether they're thin or wide, and so we would want to compute the ratio of petal width and length for each flower. Or we may want to summarize the data. For example, we may want to compute the mean and standard deviation of highway mileage for each class of vehicle in the MPG dataset. Or we may want to subset the data and get different classes, different combinations of, let's say, class and transmission type, and then compute the mean and standard deviation, and so on. Although it's possible to do these kinds of data transformations in many ways, including writing your own code to do so, we will be focusing on a very powerful package in R known as dplyr, for dplyr. And dplyr is part of a collection of packages known as tidyverse, and together these packages make it quite easy and convenient to manipulate datasets, transform data, or wrangle data, as some people like to call it. And to illustrate how to use dplyr and tidyverse, we will be also using the NYC Flights 13 library, and it contains all information about all 337,000 flights that departed from New York City area airports in 2013. So now let's go ahead and load these libraries up. So we'll load tidyverse, and which is a collection of packages including dplyr and also ggplot and NYC Flights 13. And when we do this, R gives us a few warnings. For example, it warns us that dplyr filter, so a function in dplyr, is redefining a pre-existing filter function defined in the stats package. In other words, dplyr filter is masking the filter function, and if we want to use the filter function that comes in the stats package, we should use stats : filter, whereas if we just use filter, it'll use dplyr's version. The main thing that NYC Flights 13 provides is a data frame known as flights. Flight is actually a tibble which is similar to a data frame, but it has additional features such as grouping. And we can always use the view function in the console to open up the dataset, and you can see even though it's a tibble, it looks just like a data frame that we are used to. There are rows and there are columns, but dplyr also provides an additional function known as glimpse, which provides a summary of a tibble. So we can use glimpse to look at the flights tibble, and it'll tell you how many rows, how many columns. And the one thing to be careful about the glimpse view is that in order to show you how each column looks, the columns are being shown horizontally. So each one of these is a column, which is also indicated by the dollar symbol over here. dplyr provides various functions for transforming tibbles. For example, we might be interested in identifying all the flights that are arriving in the IAH, or the Houston area airports, and assign that to a variable. We can do this using the filter function of a dplyr. For example, we might say flights IAH is filter, and the first argument of filter is going to be our data frame, and the second argument of filter is going to be a logical condition based on one of the variables or the columns. So in this case, since we are looking at flight arrivals, we are interested in the dest column of the flights table, and we might put the logical condition dest is equal to, so the equality comparison to IAH. Remember to quote it because it's a string. And what filter does is it subsets or filters the table with and keeps rows for which this logical condition is true, and it returns this filtered, this subset table, which is still a table, and we are assigning it to a variable. And so this if we try to determine what kind of an object flights IAH is, we could do class flights IAH, and we could also look at the class of flights. We run this, it says tibble df, tibble data frame. So filter is taking a tibble and then subsetting it and then returning another tibble. And now if we were interested in determining how many flights arrived in the IAH Houston area airports during 2013, we could simply count the number of rows of flights IAH, and there was 7,198 flights arriving into IAH departing from the New York City airports. Now, another type of data transformation task that one might want to perform is to compute averages. For example, we may want to know in this flights IAH table what is the average number of flights arriving each day of the year. Now, if we just simply go ahead and compute the average in this flights IAH table, it'll give us the average over the entire year. In order to accomplish computing the average for each day, we have to group the observations by day, and this can be accomplished using the group by function. And so I will say flights IAH grouped is group by, and the first argument would be the flights IAH table that we just created using the filter function. And then we will specify groups, and to say that we want each day of the year, we have to group by the combination of year, month, and day. And when I look at the flights IAH grouped table with the glimpse function, the table doesn't seem to have changed very much. It's still got 7,198 rows, so 7,198 flights, 19 columns, except one new category has appeared, which is groups, and it says it's grouping with the combination of year, month, and day. and there are 365 groups in all, which makes sense since there are 365 days in the year, and this table only contains observations from 1 year, which is 2013. Having done this, grouping the observations in the way I would like to compute the mean, I can go ahead and actually compute the mean. And for this purpose, I'm going to use the summarize function provided by dplyr. And I'll say flights IAH grouped, and now this will be the summary. So flights IAH grouped summary is summarize. Once again, the first argument is going to be my previous table, which is flights IAH grouped, and then I will say mean arrival delay is equal to mean. R and dplyr has a built-in function called mean, which will compute the mean over the built-in R function computes means over vectors. But in this case, you just give the name of the table column, which is arrival delay, and it will compute the mean according to the groups and create this new data frame. I can go ahead and glimpse this new table that we are about to create, and this new table has only 4 columns: year, month, day, and the mean arrival delay, the column that we added using the summarize function. And the mean arrival delay is the average delay over all the flights that arrived on 1st of January, the 2nd of January, 3rd of January, and so on. And we see, for example, that on the 4th of January, there was a negative arrival delay, which means on average flights arrived early by 3 minutes on the 4th of January at IAH. Now, in doing these tasks, we have been using a lot of intermediates. For example, when we filtered the flights table, we created the flights IAH table, and then we passed the flights IAH table as the first argument to group by, and created flights IAH grouped, and then this intermediate was passed to summarize as the first argument to give us the final table that we were interested in. So there is a lot of repetition and inefficiency in writing the functions this way, where you have this extra argument, which is the intermediate, and then you also need to create a variable to store the next intermediate. dplyr provides a very convenient and efficient syntax that avoids creating all these intermediate variables and passing these intermediate variables on to the next step of the computation. And this is accomplished with what is known as the pipe operator. So let's say we want to go straight to the result without saving all these intermediates. We will save to the flights IAH grouped summary table, which is our final result. And what we do is we start with the flights dataset and use what's known as the pipe operator. So this pipe operator, the vertical bar followed by a greater than sign, pipes, which you should think of it as the data going into a pipe and flowing to the next step of the calculation. And the next step is to filter, And when we're using the pipe operator, we can skip the first argument, which is the tibble or the data frame, because it's understood that you are sending the data set in the pipe. You don't need to keep specifying the name of the data set. And so we will just have the second argument of the filter function, which is the logical statement saying that the destination should equal IAH. And then whatever is the output of this filter, that tibble can be piped to the group by function. And once more, we will skip the first argument, which was the tibble, because that tibble is being piped through to group by, and we can just give the next arguments, which is the combination of groups, which is year, month, and day that we want. And this the output of group by, which is also a tibble, can now be piped to the final step of the calculation, which is summarize. And once more, we'll skip the first argument and we'll say the second argument is mean arrival delay is equal to mean of the arrival delay. Now, one cool thing when using this pipe syntax is you can see that our studio is auto-filling, so it's all auto-suggesting the variables inside the tibble, and that's because the tibble is being piped in, and the dplyr recognizes it and lets our studio show you the variables. Whereas in the previous way of doing it, we had to know the names of the columns of the dataset. And here I can use tab to tab complete, and that finishes the task. And I can once again glimpse this new tibble, and it's exactly the same result that I had before, but the code is much more concise and easy to read, where you interpret this pipe operator as a pipe that is allowing the data to flow into the next step of the calculation. In fact, I can even flow the data into the glimpse function, and this pipe operator will work not just for these dplyr functions, but any function that takes a data frame or a tibble as the first argument, including, for example, ggplot. And of course, glimpse had only one argument, which was the tibble. Since we are going to omit the first argument, we will just leave the parentheses empty. And in this case, we don't need to assign to a variable, since we just want to glimpse. And if I get rid of the previous output and run this code chunk, I'm provided directly with a glimpse of the tibble. Of course, in normal usage, I would want to assign the output to a variable so that I can do more things with it and inspect it at my leisure.